Welcome all, dear students, for the third semester. I am going to take you the radio communication, unit 2, and I have already given you the 5 PPT and 5 lessons. Now I'll give you the videos for that. Let us start the first PPT, session 1. In the first PPT, session 1, in the subject radio communication. So in the first PPT, session 1, in radio communication, you will start from frequency modulation denoted by FM. FM is nothing but frequency modulation. Okay, before going to study the wave nature of the frequency modulation and analytical treatment of the frequency modulation, let me give you some brief introduction. I think you are already familiar with unit 1 starting, which defines the communication system and modulations. However, since I am starting now, I will give you some brief introductions. What is a wave and what is a signal? What is communication and what is radio communication? Now we will discuss only about radio communication. Communication means transfer the matter from one point to another point, that is communicate. Radio communication means communicate or transmission of message signals. The message signals are usually our voice signal, speech, musics, etc. etc. Our voice signal can be heard by human ear only if it has a frequency ranging from 20 Hz to 20,000 Hz. 20 Hz to 20,000 means 20 kilohertz. How the wave is produced? Now I am speaking, that is, I am giving energy. This energy is transmitted to the particles of the medium. The particles acquiring this energy begins to vibrate from its rest position. This vibration is transferred from one particle to another particle by supplying energy. Here the particle will never move. It simply vibrates at its rest position. But from one particle to another particle, the energy is transmitted. It is in the form of wave. The human voice, speech, etc. Example, what I am speaking now is mechanical wave. They are producing by vibration of the particles of the medium. But radio communication is a system which consists of many electrical or electronic circuits used to communicate our message signal. In the radio communication, voice is generally the message signal. This message signal has frequency ranging from 20 Hz to 20 kilohertz. Below 20 Hz, it is called infrasonic. Above 20 kilohertz, it is called ultrasonic. Therefore, only you can hear the sound if the vibration occurs between 20 Hz to 20 kilohertz, and a range of frequency from 20 Hz to 20 kilohertz such that it is audible. It can be listened or hear by the human ear is called audio frequency, and therefore this message signal is also called audio signal. Both are same. Now, in the first unit, I think you have already studied that this message signal by itself cannot be transmitted to a longer distance. Even if you speak with maximum frequency 20 kilohertz, it can be transmitted only 1 kilometer, not more than 1 or 2 kilometers if the surrounding is silent. But the purpose of communication is to communicate our message signal to a larger distance, from Mysore to Bangalore, from here Mysore or Bangalore to some Delhi, or all over the world. Sometimes we have to transmit our message signal from the earth to the satellite and etc. So let us signal an electrical signal wave. So every electrical signal wave has three characters. What are these three characters? Simply I will explain this here. Okay. See, this is a wave. When this wave is converted into a electrical voltage by microphone, this signal is called electrical signal. The mechanical wave is called electrical signal after it converts from microphone. Now this signal has three characters. See this wave. From here it starts, travels through this distance. This is one complete wave. Therefore, this length traveled by this one complete wave is known as wavelength lambda. And if you mention the x-axis as a time axis, the wave takes some time to travel from year to year. I will represent this as t, where capital T is called period. This is defined as time taken by one complete wave. And also, number of waves this occurs in 1 second is called frequency. So this is one complete wave. It takes some time t. If this wave frequently repeated in 1 second, this is called frequency. The wave which is frequently repeated in 1 second is called frequency, or simply the number of waves occur in 1 second is called frequency, and it is denoted by f. See, there is a definite relation between frequency and period. What is that relations? Assume that the period of one wave is say 0.1 second. How many waves you get for 1 second? The number of waves in 1 second is called frequency. For 0.1 second you get one wave. For the next 0.1 second, that is for 0.2 second you get two waves. For 0.3 second you get three waves, etc. For 0.9 second you get 9 waves, and for 1 second you get 10 waves. That is, if the period of one wave is 0.1 second, then for 1 second you have number of waves 10. That is called frequency. Now I will write f as number of waves in 1 second like this: 1 over zero point 0.1 second. That is 0.1 second is period. So 1 over 0.1 second is 10. Unit is hertz. Unit of frequency is hertz. Therefore, we can say that f is equal to 1 by t, where t is the period of one wave. Now, this is one character of a given wave. One important characters of a wave is the number of waves occur in 1 second, known as frequency. So the first character is called frequency. Let us come to the next. You see, if you take this as a voltage axis and x-axis as a time axis, sometimes x-axis is also considered as angle axis. The voltage at this point is 0, gradually increases and reaches the maximum value at this point. This is the maximum value. Again decreases from maximum value to 0. Again increases to maximum value, but in a negative direction. This is positive direction. This is negative x-axis, so negative direction. Here also you have a maximum voltage negatively. Again it decreases to 0. Thus, a wave continuously changes in its voltage. The maximum voltage of a given wave, either on the positive side or on the negative side, is called amplitude. Therefore, second character, very important characteristics, is called amplitude. If I represent this as a voltage, small letter E, I will represent the maximum amplitude as capital E. So, E is the amplitude. That is the maximum value of a given wave, either on positive cycle or negative cycle. Another example, another characteristics, it is also main characters. See this way. If I represent x-axis as a theta, and for one complete wave, it takes an angle 360 degree, that is 2 pi. Half of the wave will take pi. This is 1/4 of the wave, that is pi by 4, means 90 degree. This is 180 degree. This is 270 degree. Now see this wave. This wave does not start from the origin. It starts after some angle. The wave is obtained. Let this be angle is pi. Pi minus 0 is pi. This angle is pi. This is called phase angle. Suppose if one wave starts from the origin and another wave starts from after some angle pi, the phase difference between these two waves, pi minus 0 is pi, is called phase angle. This is one more characteristics, important characteristics. Therefore, a wave must be completely defined by three characters, namely frequency, number of waves in 1 second, maximum height of the wave on either side, positive side or negative side, called amplitude, and elapsing angle or phase angle pi. Therefore, accordingly, we have three types of modulation. In Unit 1, you have already studied the amplitude modulation. Now, I will consider this wave as message signal wave. Message signal wave, or simply audio signal wave. It is also called modulating signal. The signal which is to be changed or modulate is called modulated. This message signal has to be changed. But there is another frequency used in radio communication for the purpose of transmission of this low frequency, and this frequency will carry this low frequency. Therefore, this is called carrier signal. Since this is a very high frequency used for the purpose of radio communication, it is also called radio frequency. Radio frequency. This is also called carrier frequency signal. So, radio frequency signal or carrier signal is very high frequency signal used for the purpose of radio communication. See this equation. F is equal to 1 by T. Our message signal is low frequency. How do you get low frequency F? F is small when T is very large. Denominator. F is small. F is small when T is large, greater. Therefore, period is time taken for one complete wave. If this represents the message signal, a low frequency signal, period is large. Therefore, to represent RF, that is high frequency radio frequency signal or carrier signal, period must be small, because from this expression, if T is small, F is large. The frequency is very large when T is very small. Therefore, I will write one complete wave of radio frequency with small period. See this, where T is very small compared to this. Therefore, this represents message signal and this represents carrier signal. I will write the number of waves in 1 second. This is our radio frequency signal, also called carrier frequency signal. Of course, every wave is explained by three important characters. Number of waves in 1 second is called frequency. Since it is carrier frequency, I will represent this as FC. FC. Another one, the maximum height of this frequency, so the maximum height of this voltage, carrier voltage, I will represent this as EC, carrier voltage along y-axis, and angle along x-axis. The maximum height either on positive side or negative side is called amplitude. I will represent this as E suffix C, carrier amplitude. I will represent this as E suffix C, carrier amplitude. And the third one is, here the wave started from zero. If it starts from after some angle, that is known as phase angle. Therefore, another third characteristic is phase angle. I will represent this as pi c. So, accordingly, we have three types of modulation. We are going to discuss about only FM modulation. FM modulation. But however, I will define all types of modulations. See, modulation is nothing but changing the characteristics of this high frequency, any one characteristics of this high frequency must be changed in accordance with this modulating signal, in accordance with this message signal. That is called modulation. So modulation is nothing but changing the characteristic of a high frequency signal as the amplitudes of low frequency signal. See here, since it has three characteristics of high frequency 3, first I will keep F, E and C constant among three characters. I will keep EC and FIC, that is amplitude of this carrier signal, phase angle of the carrier signal constant. And when this FC, carrier frequency, is changed in accordance with the amplitude of this modulating signal, it is called frequency modulation. So, definition of frequency modulation is changing the frequency of the carrier wave. Changing the frequency of the carrier wave, keeping carrier amplitude and carrier phase angle constant in accordance with this modulating signal. Therefore, FC is changed in accordance with EM. This is frequency modulation. In amplitude modulation, how do we define? We will keep frequency and phase angle constant. Phase angle, frequency constant. We will change the carrier of the carrier amplitude of the carrier signal in accordance with this modulating signal. That is amplitude modulation. Of course, if FC and EC, both frequency and amplitude of the carrier signal are kept constant, only if the angle of carrier signal is varied in accordance with the modulating signal, this is called phase modulation. Now, let us discuss about FM modulation. This is your topic. Unit 2 starts from FM modulation. In FM modulations, first we will study the graphical representation. The graphical representation consists of representing the message signal, representing the carrier or radio frequency signal, and representing the resultant frequency modulated signal. Let us consider how we can represent. Let us consider how we can represent the frequency modulated signal. Okay. First, I will represent the low signal, that is message signal. It is also called audible signal because this signal can be heard by human ear. It is audible. The low frequency has higher period because f is equal to 1 by t. If t is large, f is small. And I will take only one wave for graphical representation. Now, when I speak, it produces number of waves and number of amplitudes of varying amplitudes. But for graphical study and for analytical treatment, let us consider a one wave of modulating signal, that is message signal. Let small letter e m represents the modulating signal voltage. Then I will write the graph, that is I will represent the modulating signal like this. Where period is large, therefore frequency is small, and therefore this is called message signal, also called audio signal. See, this is the maximum voltage of this EM. I will represent this as modulating amplitude of modulating signal. This is also maximum height, but on the negative side. This is also amplitude of modulating signal represented by EM. Now I will represent the carrier signal here. Since the carrier signal has very high frequency, its period should be very small, and I will write a small period signal 1, and I will consider number of waves of carrier signal. So write the small period signals, equal time period, all signals, all number of waves have equal period. While writing you may find some differ, but just think that all wave of this carrier has same period. Period remains constant. Since the period is very small, frequency is very large. Therefore, this represents as carrier signal, and I will represent y-axis as carrier voltage EC, and the maximum height or maximum voltage of this carrier signal is referred as carrier amplitude EC. Okay, so this maximum height is called carrier amplitude, and this high frequency wave is used for the purpose of communication, and hence it is used for the purpose of radio communication, and hence it is called radio frequency signal. Since this high frequency signal carries our message signal, it is also called carrier signal. Both are the same, carrier signal or RF signal. Now I will write the frequency modulated signal. How? Let it be represented by EFM, frequency modulated voltage, say along y-axis. Now see this message signal. The message signals are 0 at the point A, at the point C, and at the point E. And in frequency modulation, the frequency of this carrier signal is varied in accordance with the amplitude of this modulating signal. And this frequency is FC. Before modulation, the carrier frequency is FC. Let us see what are the frequencies after modulation. So in FM modulations, the amplitude remains constant. Therefore, the resultant wave should have a constant amplitude EC, and the phase angle is also constant. Of course, it starts from 0. It also starts from 0. Phase angle is 0. Now, if this frequency Fc, when mixed with the 0 amplitude at A, C and E, there is no change in the frequency. Therefore, the resultant frequency of FM wave remains as Fc itself, and I will write the wave as Fc itself. Write the period as the period of this carrier wave at the point A and at the point C, same carrier frequency, and at the point E, since amplitude is 0, at the point E, same normal carrier frequency. Now see the modulating signal. The amplitude from A increases and reaches the maximum value at B. Therefore, the carrier frequency should increase from A to B because amplitude increases. Again, the resultant frequency at this maximum peak value is maximum, and again it decreases from maximum to normal carrier frequency Fc because amplitude is 0. The frequency after modulation is same as before modulation, that is Fc. From year to year, the voltage decreases in a negative manner. Therefore, the frequency of the resultant wave, that is FM wave, should decrease, and it decreases to minimum value at this minimum amplitude, and again it increases to its normal value Fc here. Therefore, at this point the frequency is maximum, at this point frequency is minimum after modulation, and also frequency gradually changes according to this signal. So it increases and goes to Fc, still decreases, again goes to Fc. Therefore, I will write the frequency modulated wave. At this point it should be maximum, at this point it should be minimum, and therefore when the frequency is maximum, the period is very small. Therefore, since frequency increases, now I will write the period is very small. It shows that the frequency increases, whereas height, that is amplitude, remains constant. So, at this point, frequency is increased to a maximum extent for positive peak value. Therefore, this is frequency Fc, no change in frequency. Here it is also Fc, no change in frequency. Here it is also Fc, no change in frequency. For this positive peak value, there is a maximum change in frequency. Let delta F is the change in the frequency. Then frequency at this point is Fc plus delta F. Now, again the frequency reduces to its normal frequency Fc because the amplitude reduces. Now write this period increases slowly to its period of carrier signal, to the period of carrier signal. Now see, the amplitude decreases here and reaches minimum value. Therefore, the resultant frequency should decrease. So I will write, since frequency decreases, the period should increase. Therefore, I will write a larger period of the wave here. And again, the frequency increases to its normal carrier frequency. Here, the positive peak value is same as negative peak value. Therefore, in the resultant frequency, how much it increases at positive value, same amount decreases at negative peak value of modulating signal. Therefore, here it is frequency is Fc minus delta F. This is a frequency modulated wave. Therefore, this is frequency modulated wave. So, you see, in frequency modulated wave, carrier amplitude both is constant. Phase angle is 0, that is constant. Only frequency continuously changes according to a continuous change of the amplitude of the modulating signal. Now the frequency changes from Fc minus delta F to Fc plus delta F. Minimum frequency is Fc minus delta F and normal frequency is Fc, mid frequency of this, and again increases to Fc plus delta F. Therefore, delta F is called deviation from the normal frequency. Here Fc, here Fc, here Fc, here Fc, Fc. But here it is Fc plus delta F, here it is Fc minus delta F. Therefore, there is a gradual increase here. Similarly, there is a gradual decrease here. That is deviation from Fc. Therefore, delta F represents the deviation in the carrier frequency after modulation. This deviation in frequency depending upon the amplitude. Therefore, we can write the deviation frequency delta F is directly proposed to our modulating or message signal M. Now, let us consider instantaneous value of this frequency. When do you consider instantaneous value? When there is a continuous change in occurs. Then the value at any instant is called instantaneous value. Here there is a continuous change in frequency. Therefore, if you take a frequency at any instant, that is called instantaneous frequency. Therefore, the instantaneous frequency of this modulated FM, modulated signal, is Fy, which is equal to Fc either plus or minus delta F at any instant you can take. This is instantaneous value. So, this is graphical representation of modulating signal, carrier signal before modulation. Since this frequency is high, you can also call this as carrier signal, radio frequency signal, but change in frequency. This is frequency modulated wave. Now let us study about analytical treatment. Let us study about analytical treatment, that is derivation of instantaneous value of frequency modulated wave. See, this is what it is, a sine curve, and maximum voltage is Em, and the instantaneous value is Em. Therefore, the equation of this is represented by Em is equal to capital M, maximum amplitude, into sine of omega mt, because it is a sine curve, and where frequency is Fm, modulating frequency. Here omega m is angular frequency, and you know that the relations between angular frequency and angle theta is omega is equal to omega into t equals theta, or omega is equal to theta by t. That is, angular displacement divided by time is known as angular velocity or angular frequency. Now, since angular frequency changes, FM modulation is also called angle modulation. I will tell you why. Now see this. This is a carrier frequency. It is also a sine wave, but maximum amplitude here it is represented EC. Therefore, equation of this wave is EC is equal to, that is, carrier voltage is equal to its maximum voltage EC into sine of omega CT, where omega C is called angular frequency of carrier signal. And it is to be noted that angular frequency is obtained how? If f is the linear frequency, what is the total angle of a wave? Total angle of a wave is 2 pi, that is equal to 360 degree. This is 0 degree, this is 90 degree, that is pi by 2. This is 180 degree, this is 270 degree, and this is 360 degree, that is 2 pi. One complete angle of a wave is 2 pi. If f is linear velocity, then if you multiply it by one complete angle 2 pi f is called angular velocity. If linear velocity is multiplied by the angle 2 pi, we call that frequency as angular velocity, angular frequency omega. Therefore, omega is equal to 2 pi f. Similarly, what is omega m? Same. It is 2 pi fm. Then what is omega c? It is same, that is 2 pi fc. Fm is modulating frequency, omega m is angular modulating frequency. Fc is carrier frequency, omega c is angular carrier frequency. Okay. Now, see, this is frequency modulated wave, where the amplitude EC remains constant. Only angle changes. That is frequency, it occurs in angle changes. Since angle changes, it contains frequency. Frequency modulation, also called as angular modulation. Similarly, phase angle also occurs in angle. Phase modulation is also called angle modulation. Now, what is the voltage of this? EFM is the voltage of frequency modulated wave. Therefore, I will write this as EFM, voltage of the frequency modulated wave, is equal to, since amplitude remains constant, it is EC itself. The resultant wave is also sine wave. Therefore, this is sine of, just I will write theta, because angular frequency continuously changes. That I don't know. First I will write that is an theta. Now, analytical treatment. Study the analytical treatment of frequency modulated wave. Analytical treatment of frequency modulated wave. See, the modulating signal is represented by Em equals Em sin omega t. The carrier signal is represented by Ec equals Ec sin omega ct. Similarly, the frequency modulated signal voltage, that is EFM, is represented by Ec sin theta. Okay, I will write this here. Let the modulating voltage or message signal, modulating voltage, also called or message signal, is represented by Em is equal to capital Em sin of omega mt, which is equation 1, where Em is equal to capital EM sin of. You can write this omega m as 2 pi Fm into T because omega equals 2 pi F. Similarly, the carrier voltage or signal, both are same. The carrier signal voltage or carrier voltage signal are also called radio frequency voltage signal voltage is given by EC is equal to capital EC sine of omega CT. Actually, this is omega CT plus pi C, but pi C is taken as 0. Have taken the wave starting from origin. Carrier phase angle phi 0. Therefore, simply EC is equal to EC sine of omega CT. Call this as equation 2. This can also be written as EC is equal to capital EC into sine of. We know omega is nothing but 2 pi. Omega is 2 pi. Therefore, this is 2 pi Fc into T. Now, what is Fm? The Fm voltage, instantaneous value, instantaneous voltage of Fm, instantaneous voltage of Fm is represented as EFM. Carrier amplitude remains constant into sine of theta. Let Fi is the instantaneous frequency of frequency modulated wave, which is given by Fc plus or minus delta F, where carrier deviation delta F, which depends upon the modulating signal EM, because in frequency modulation the carrier frequency deviates according to the modulating signal. The carrier frequency changes according to the modulating signal. That is, delta F is proposed to EM, or delta F is equal to some constant proportionality Kf. This is called constant of frequency variation, proportionality constant of frequency into EM, which is equal to Kf. What is EM? Our modulating signal given by EM into sine of omega mt. Okay. Therefore, instantaneous frequency is Fi is equal to Fc plus or minus delta F is nothing but Kf Em sine of omega mt. And we know that the angular frequency omega I is given by the rate of change of angular d theta I by dt. Or from this equation, d theta I is equal to cross multiplication omega I into dt. Now, d theta I is equal to omega I is nothing but 2 pi Fi into dt, because we know that omega is equal to 2 pi F. Therefore, omega I is 2 pi Fi. Substitute Fi here from this equation. So you get d theta I equals 2 pi into Fi is nothing but Fc plus or minus Kf Em sine omega mt, okay, into dt. Or d theta I is equal to 2 pi Fc multiplying by 2 pi and also by dt. 2 pi Fc dt plus 2 pi Kf Em sin omega m into dt. 2 pi kf em sine of omega mt into dt. Now integrating on both sides. Integrating on both sides. So when you integrate on both sides, we get integral of this, integral of this, integral of this. We know that the integral of dx is x. Similarly, integral of d theta I is theta I, which is equal to, here 2 pi fc constant, 2 pi fc constant, and integral dt is t itself. Here plus or minus you have, okay. I will write this plus or minus here. 2 pi kf em constant, 2 pi kf em constant. Integral of sine omega mt dt is minus, I will write plus or minus cos of omega mt divided by derivative of omega mt with respect to t, it is omega m. Therefore, theta I is equal to 2 pi fc means omega ct, plus into minus minus, minus into plus plus. Therefore, again you get here minus plus, both are same. Therefore, I will write plus minus itself. Or to clarify mathematically, I will write minus and plus, both are same. 2 pi kf em into omega. What is omega m here? Omega m is nothing but 2 pi fm. 2 pi get cancelled. You get kf em divided by fm into cos of omega md. Now in general, I will write this as theta I is equal to omega ct plus or minus mf into cos of omega mt. Call this equation as 4. See equation 3. This is equation 1. And this is equation 2. And this is equation 3. I will write instantaneous value as EF, theta I, because we are going to derive an instantaneous value of frequency modulated wave, which is equal to E sine of theta I, where theta I is the value at any instant. Okay. Now what is theta I? Substitute this theta I, which is given by omega ct plus or minus mf cos of omega mt. That is substituting equation 4 for theta I in equation 3. So you get EFM, instantaneous voltage of frequency modulated wave, equals EC, carrier amplitude remains constant, sine of theta I. Theta I is omega ct plus or minus mf cos of omega mt. This is the final expression of instantaneous voltage of frequency modulated wave. This is analytical treatment. Now, instead of MF, what is MF? See here. KF EM by FM is here. Instead of writing KF EM by FM, I have taken MF. Therefore, MF here written is equal to KF EM by FM. ಪದೇ ಪದೇ ಇದನ್ನು ಬರೆಯೋ ಬದಲು MF ಅಂತ ಬರ್ಬಿಟ್ಟಿದ್ದೀನಿ. Therefore, MF is equal to KF EM by FM. Where MF is equal to KF EM by FM. This MF is called modulation index. Modulation index in frequency modulated wave. So in amplitude modulated wave, we have represented this as MA. That is modulation index in amplitude modulated wave. Here it is MF, modulation index in frequency modulated wave. In phase modulation, while discussing that, we will write MP, modulation index in phase modulation. Since this is angle modulation and phase angle is also angular modulation, expression for modulation index MF and MP both are same. Now let us define what is modulation index. By definition, modulation index of frequency modulated wave. So modulation index of frequency modulated wave. We know that delta F is carrier deviation, which is directly proposed to EM. Our delta F is equal to KF into EM. That is equal to KF into EM is nothing but modulating voltage is given by capital EM into sine of omega MT. What is delta F maximum? So maximum carrier deviation occurs at maximum amplitude of the message signal. What is the maximum value of delta F? The maximum value of this. What is the maximum value of sine theta? Sine omega MT is 1. Maximum value of sine theta is 1. Maximum value of cos theta is 1. Okay. So maximum value of all trigonometrical function is 1. Therefore, if delta F equals KF EM sin omega MT, then delta F maximum is KF EM because this becomes 1. I will call this delta F maximum as carrier deviation delta, where delta is defined as maximum carrier frequency deviation from its normal carrier frequency Fc. Now the modulation index MF is defined as the ratio of maximum carrier deviation, frequency deviation, maximum carrier frequency deviation, or deviation of the carrier frequency, maximum deviation of carrier frequency delta divided by Fm, because MF equals KFEM. KFEM is delta. Therefore, MF is equal to delta by Fm. So, this is the modulation index of FM wave. So, in definition, we say that modulation index of FM wave is defined as the ratio of maximum carrier deviation from the normal carrier frequency to the maximum modulating frequency. FM is called frequency of message signal or frequency of modulating signal. Therefore, modulation index in FM wave is the ratio of maximum change in the carrier deviation to the maximum modulating signal. Because when you speak, we get number of modulating signals, number of message signals. Among those, which is maximum frequency of the modulating signal, that frequency has to be considered. So, this ends the PPT 1. Thank you. Let us study about PPT 2 next time. Thank you.